Welcome back, friends. In the previous session we were discussing about group 1 element, which are the alkali metals, and in this session we are going to continue with our discussion, and we are going to discuss about the alkaline earth metals. So all group 2 elements have 2 electrons in the outermost orbitals. The electronic configuration of group 2 element ni kama ambavyo unaweza kuona kwenye table. So we have beryllium, the first member, followed by magnesium, calcium, strontium, barium, and then finally is radium. So electronic configuration inakuwa na 2 electrons in the s orbital. Group 2 elements are called alkaline earth metals because most of their oxides existed in the earth's crust and were alkaline in nature. Most of their oxide existed in the earth's crust and they were alkaline in nature. So the alkalinity or the nature of these oxide is what made them to be called as alkaline, and because they were found in the earth's crust, that's why they are called the alkaline earth metals. So all group 2 elements have the outer shell electronic configuration of NS2 and therefore they are S block elements kama ambavyo zilikuwa group 1 element. Group 2 elements are electropositive but less electropositive than alkali metals. So zina uwezo mkubwa kudonate electron, lakini uwezo wake hauwezi kufananishwa na ule wa sodium au ule wa alkali metals. Group 1 they are most electropositive. First member of the group, beryllium, is anomalous. Kivipi? This because beryllium is smaller, less electropositive, and has a higher polarizing power than the rest of the member. And we should discuss about this anomalous later when we are going to continue this discussion in group 2 elements. Now let's move to the physical properties of group 2 elements. Group 2 atoms are large but are smaller than the corresponding group 1A elements. So group 2A atoms zenyewe ni kubwa lakini ni ndogo kikompare na atoms za group 1A elements. The extra charge in the nucleus draw the orbital electrons. Similarly, their ions are larger but smaller than those of group 1A because the removal of 2 electrons increases the effective nuclear charge even further. So that's about the atomic size and ionic size. They have higher density than group 1 metals. Hiyo ni kwa sababu ya stronger metallic bond inasababishwa na contribution of 2 electrons into the electron cloud, but also the smaller atomic size. Number 3, they are harder than group 1 elements. Again, the reason is metallic bond. Number 4, they are very high. They have high melting and boiling point than high melting and the boiling point than the alkali metals because of the presence of 2 valence electrons that are involved in metallic bonding. That is number 4. Kwa hiyo again the reason is strong metallic bond. Number 5, since the atoms are smaller than those in group 1, the electrons are tight held so that the energy needed to remove the first electron and the first ionization energy is greater than for group 1. Kwa hiyo group 2 elements they are smaller na electrons zimevutwa zaidi towards the nucleus. Kwa hiyo energy inayotakiwa ili kuweza kuremove electron itakuwa ni kubwa. They have greater ionization energy than group 1 element. And number 6, the electronegativity of electronegativity values of group 2 is low but are higher than that of group 1. So group 2 element zina electronegativity ambayo ni ndogo, lakini ni kubwa kuliko group 1, kubwa kuliko group 1. About the chemical properties of group 2 elements. Group 2 elements are highly reactive and thus never found in free state. Kwa hiyo the reactivity increases down the group due to increase in atomic radius down the group. Kwa hiyo group 2 elements, they are never found as unreacted, yani kukuta iko free state and reacted hazijapatikana. So alkaline earth metal burn in oxygen forming oxides. For example, calcium and magnesium zina burn in oxygen kutengeneza oxide kama hivyo. When heated in nitrogen, hiyo ni reaction ya kwanza, burn in oxygen to produce oxide, au unaweza kusema reaction with oxygen. Lakini namba 2, when heated in nitrogen, alkaline earth metals form nitrides. Alkaline earth metals form nitrides. These nitrides are colorless crystalline solid which react with water to liberate ammonia. So unaona mfano ni sodium nitride, calcium nitride, ambayo calcium nitride reaction na water pale tunaenda kuform calcium hydroxide and ammonia, calcium hydroxide and ammonia. And number 3, carbonates of group 2 elements. Carbonates of group 2 elements decompose when heated, giving the corresponding oxide and the carbon monoxide. So zina decompose kutupa oxide na carbon monoxide. The stability of carbonates increases down the group. Hiyo ni kwa ajili ya nini? Packing the particles. So moving down the group, the size of an element inakuwa kubwa, but also the space for packing materials is also large. Kwa carbonates of group 2 element, they decompose when heated, lakini the stability of carbonate increases down the group. Number 4, alkaline earth metal react with carbon forming carbide, except beryllium that gives methanide. So methanide is beryllium C, but other compounds they form carbide, ambayo hapa C inakuwa na mbili, that is carbide. So number 5 is reaction with water. And about the reaction with water, is elements zinakuwa zina react na water, matokeo yake yanakuwa tofautiana. For example, beryllium is much less electropositive or less metallic, much less electropositive or less metallic than the other, hence it does not react with water. Hiyo ni beryllium. Calcium na hao wengine watatu, being quite high in electrochemical series, they react with cold water quite readily, liberating hydrogen and forming metal hydroxide. Wanatengeneza hydrogen pamoja na metal hydroxide. Naona. So baada ya hapo tuna magnesium, ambayo react with boiling water or steam to form magnesium oxide and hydrogen gas. Kwa ile reaction ya magnesium na reaction ya magnesium na water ambayo nilieleza kule nyuma kwenye period 3, we also repeat to read it in group 2 elements. Anomalies of beryllium at the first member of group 2. Kwa unatakiwa ujue hapo, unatakiwa ujue so basic reaction, huyu react na huyu kinatokea nini, kwa nini kitokea hiki. So for most of cases the anomalies they are seen, anomalies are seen in the first member, and in our case the first member is beryllium. First, it is extremely small. Fajans rule state that the small highly charged ions tend to form covalent compound. So the compound formed between beryllium and any of the nearby state said that these compounds, they are covariant in nature. The compounds are covariant in nature. Number 2, beryllium has a comparatively high electronegativity. When reacted with another atom, the difference in electronegativity is large, which again favor the formation of covalent compounds such as beryllium fluoride and beryllium oxide. All of these, they are just examples of the covalent compounds. Kama nilivyosema hapo juu kwenye covalence, beryllium hydride is electron deficient and polymeric with multi-center bonding like aluminium hydride. Kwa hiyo yenyewe ni electron deficient species, ni species ambayo inakuwa ina electron. Ni pia B form beryllium form many complex. Tutaenda kuona kwa mbele. Beryllium hydroxide like aluminium hydroxide is amphoteric. Kwa hiyo ina behave na properties za base na zile za acid, za base na zile za acid. So last, beryllium like aluminium is rendered passively by nitric acid. Let us end up here. In the next session, we'll be discussing about the concept of diagonal relationship and its implication. So thank you everybody, and let me wish you nice studies.